Welcome to the last lecture of the course, MATLAB and Mathematics. Okay, so we're gonna look at the simple statistic functions MATLAB has to offer. You've already seen functions like min and max. So I'm just gonna go a step ahead and talk about maxk and mink, which might be relevant to you. Okay, so given a matrix A, you are already aware of how to get the minimum value as well as the index. So right there, 20 is the minimum and the index of 20 is 5. And it's always better to name your output arguments with a meaningful name rather than naming them A and B. Anyway, now mink, like the name suggests, is going to give you k minimum values. So if I say mink of a, 3, then starting with 20, I'll have 25 and 26 as well. On the other hand, if I ask for maxk of a, 3, so I have the maximum values, 3 maximum values in that vector showing up. Like any other function in MATLAB, when you apply mink or maxk on a matrix, it's going to apply it column wise. So you would get 3 minimum values from each column. Let's look at the statistic functions mean, median, mode, standard deviation, as well as variance. Mean function will compute the mean of all the values in a vector. Mode finds the number that repeats itself the most number of times. And median is the center value of the vector when it is sorted. Now for a vector with like even number of values, there won't be any center element. It's going to be the average of those two elements up there. Let me create a vector with odd number of elements. So the median for this vector would be 3. Let me jumble this vector a bit. I'm going to place 2 at the center and 3 up there, but it doesn't affect the median function. So it's going to sort it and then find the center element. Well, if you have data with only a single number, there's not going to be any deviation or variance. So let's try to apply that on data which has some kind of variance. Okay, so MATLAB has inbuilt functions std for standard deviation, var for variance. And MATLAB also supports set operations like union, intersection, as well as finding unique elements in a particular set. So let's see how to find the union of two different sets. We have A and B here. If I say union of A, B, I'm going to have the union. So intersection is the common elements of A and B, which are 2 and 3. Okay. Let's look at the function where we can find the unique elements in a given set of numbers. So here the unique elements are 1, 2, 3, 4, and 5. So I can get that using the unique function. Now let's see how to fit curves using polyfit and polyval. Okay, so let's talk about polynomials in general. A first degree polynomial has 2 coefficients, a and b. Second degree polynomial has 3 coefficients, a, b, c. Third degree polynomial has 4 coefficients. Okay, so with the increase in the degree or the order, the complexity of the plot changes. Now we're going to fit curve to the data shown here. It's a temperature data. So I have my x-axis, which is the time, and y-axis, which is the temperature. I'm going to start with polynomial of first order. Okay, so like I said, a first order polynomial has 2 coefficients. Those 2 coefficients are going to give you the equation for the straight line. Now, to be able to plot, we have to get the points on the straight line, right? So that is what polyval is for. So polyval takes in the coefficients as well as the x-axis input and gives out the, the curve values that we have. So let's see the visualization. Yeah, so it's going to be a straight line. So that is the best fit curve for the data. So let's examine the coefficients that we have. Yeah, so because it's a first order polynomial, you have 2. Now let me try to fit a second order polynomial, okay, so and see how it looks like. I'm gonna make the required changes. So I changed polyfit of x comma y to 2, and the coefficients are gonna be 3 this time. So let's try to validate that. Yeah, so this looks like a parabola, which is what a second order polynomial looks like. Let's see the coefficients. They're gonna be 3 of them. Okay, so I'm gonna extend this further. Let's try to look at a third order polynomial, and we'll do a fourth order polynomial as well later on. So I'm using different color coding to show you those plots. So the red one is a third order polynomial. So I'm gonna use the polyfit of x comma y comma 4 to get the fourth order polynomial. So I'm gonna use magenta color for visualizing it. With the increase in the order of the polynomial, you see that it fits better and better to the data that we have. Anyway, so let's move on to the next topic, which is symbolic mathematics. So symbols in MATLAB are very, very useful. You'll see very shortly as to why. So the way to define symbols in MATLAB is to use sims. So sims x comma y are going to initialize symbols x and y. As you can see, the class of x is a symbol. MATLAB treats x and y as symbols. Now any expressions that you write there, they're going to be evaluated accordingly. Okay, so if I say a divided by b, so that's going to be x by 4. All right, so class of a as well as class of b, they're going to be symbols as well. Now if you have like complex expressions that you want to expand, so let's try to expand this very basic equation. So it's x squared minus y squared, you know that. But if I ask you what would be the expansion of x minus y whole power 8 multiplied by x plus y whole power 8, the MATLAB does that work for you. Okay, so let's have that expression. Now let's go a step further. So let's say we have an expression like that, and then we want to factorize that expression. So MATLAB has this function called as factor. So you can use that and then get those factorized results. Now, if a given expression does not have any factors, MATLAB would simply return that for you. But for every valid, factorizable expression, MATLAB is going to give you the correct answer. All right, I think this is like a really cool feature. Let's look at the other functions that are out there. You can also substitute a specific value in an expression. Here I'm substituting x for 3. So MATLAB is going to give me the answer. So I could substitute y for 3 and then I'll get a different answer. There are a lot more features. We'll explore them in class. See you soon.